started with a grant from NOAA to study really the reserve and how sea level rise might impact the reserve. So why St. Augustine and all the communities? Well, you clearly know, and so do we, that the human and natural ecosystems are very much intertwined, and we can't talk about one without thinking about the other in the context. Am I in your line of sight over here? Try to find a place to get out of the way. So you know my friends. Who you don't see here today are the army of researchers that we have from the University of Florida who are on this project. Engineers, scientists, biologists, landscape architects, planners, lawyers, etc. So this is a kind of, if you will, a 100-man march for sea level rise. We also have a very interesting steering committee. The role of the steering committee is really to vet our ideas and our products before we come to you. They do a lot of the early arm wrestling about which numbers and how are we going to present graphics and what issues and how do we invite people and how do we get to participate. They are a hot, dynamic, wonderful group of people that really have been very beneficial to us. We also have groups of stakeholders. So we're talking to coastal residents. We're talking to people in the natural resources and ecotourism industries. We're looking at developers who hold lands, uplands, and we're also talking to planners and leaders. So at any time we have a remarkable combination of the folks, but really part of this process is education and value setting, finding out from the community what's important so that when we start talking about the future, we can do that well informed. This is a three-phase process, as Emily mentioned earlier. So we're in phase one. We spent the first 9 months of the project, if you will, really fleshing out the issues, trying to scope the dimensions of the problem and how we were going to go about getting people to have this conversation with us. So we're at the end of phase one and we're starting to have the conversation with you. Today we'll talk about what is the most important to you in this region and how those things might be affected by sea level rise. When we come back in a year, we'll invite you all again. You'll all be on our email list and you'll have access to our website as well, which is planningmatanzas.org. If you have a smartphone, you can take a picture of the QR code and you can just have it in your phone. At that point, we're going to be talking about future development scenarios, right? And how what you value would shape the future of development if we put priorities around us. So we'll get into the planning phase, if you will. And in the final phase, we really do hope to come up with a conservation strategy for GTM and the surrounding communities so that the plans can be carried to fruition. All right, so why are you here? Well, you're here because you're interested, and that's super. Sea level rise is definitely a challenge, so we've got problems up there, but what we're approaching it as at this point is solution-oriented. How do we adapt to what's happening and make sure that the animal habitats and the human habitats are usable and healthy in the future? So today, I'm going to spend some time talking about coastal planning. We'll turn after me to the science of this area. Now, many of you have probably seen maps on television or in the newspaper of what sea level rise projections could mean. Those are very generic. We will give you a more specific landscape for this area. The team of researchers has been doing some really fine work in that area that I think you'll be impressed with. Emily will talk with you about your value setting, what's important, what makes this place special, and then we'll play, right? You've got gaming devices, so you've already had a little bit of play this time. But one thing that's difficult when we start talking about adaptation, all the strategies sound pretty good, except we realize that we live in this world of very finite resources, and you deal with that on a daily basis. So the question becomes then, how do we decide what's important to us based on what we have? And while we can't solve that problem today, we can start playing with it and give you a sense of the complexity of that. So we'll end on a high note and give you some fun role playing to do later on. So I hope you will play with us. All right, so why this project and why the Matanzas Basin? Well, you already know that this place is lovely and pristine and offers ecological services that are really unparalleled. The basin is dynamic. It's always been dynamic. This map is a 1765 map of the area. If You can see how much the area has changed over time. I think this is a great depiction of the dynamics of the area. And we take that for granted, right? We see little shifts in our lifetime, but unless we really study the place historically, we often don't remember that we've seen a lot of change in this area. And we've responded to the change, right? We've been adapting to the change for over 100 years. We armored the coast at the fort because we were worried that something historically important to us would be destroyed. Our bridges, of course, every generation of bridges needs to be repaired and revised over time, and so we try to build what we call hazard-resistant infrastructure. Now, you don't have to look too far, even beyond a month, to know that most infrastructure is not particularly hazard-resistant if we look up to our friends in the Northeast, right? It is very difficult to build something that is a perfect system, and yet we have tried to engineer some of the risk out of the system and done it successfully in a lot of places. You all know about Summer Haven and what's happening in Summer Haven, and that is a significant ecological challenge where you have the collapse of an ecosystem and the change into another. The question becomes, what do we do with it? Do we re-engineer it so we take it back to where we were, or do we allow the natural systems to take their courses? These conversations that we're having now will become more frequent as we deal with rising sea waters. So what are the trends? I love this map. Catherine and I went to a presentation in Cedar Key by an archaeologist who was talking about shell mounds in Cedar Key and the remarkable history there. And he said, I've heard about this thing called sea rise. And he said, it's very politicized on the television, and I don't really understand why. He said, there's good evidence that it's happened before. And you all know that it's happened before, right? This is not news to you. If you look at this graph, this is 140,000 years of sea level rise history, if you will. And if you look at the high point, that's where we are. We've been sitting on this high point, right? The waters have receded for a long period of time. And yet we are anticipating change, right? The change that's happening we'll talk about today and why that's happening. All right, so this is a tidal gauge from Mayport, Florida, where we measure the amount of sea level change that we have based on the tides. We have data for over 100 years, and if you look at this, the tides have risen about 2.44 milliliters a year for 100 years, which translates roughly, my research assistant assures me, because my math skills aren't so great, into about 9 inches of sea rise. So sea has been rising. This is not a new unfamiliar phenomenon. It isn't something that was magically cooked up. We do have some suggestions that it's been happening. Now this is gradual, right? 9 inches is pretty gradual. But when you think about an area like the Matanzas Basin, this is an awesome photograph to depict how a small amount of water could very significantly change an area that is already very low-lying and situated in the way that it is. Now we know that sea level rise has changed coastal areas very specifically. This is a picture from Big Pine Key. Right? Big Pine Key is very, very rapidly experiencing sea level rise changes. But this is a pine that's about 100 feet away from a grove of healthy pines. From a dead stump, right? Because the habitat changed, the climate changed. And you've seen these on the landscape, and you wonder, why is that cluster dying? Well, it is likely related to some natural ecological phenomenon like this that's occurring. So one of the most compelling pieces of evidence that we have right now that change is actually occurring is really in the water. Right? Our most precious natural resource, fresh water, right? The farmers are the first to notice these changes always because they are irrigating their crops, they're drawing from wells, and what they're getting is a crop with brown leaves, and the brown leaves are typically an indication of high saline levels in the water. We know that farmers in the county have drawn salt water out of their wells, right? So this is a phenomenon that is occurring that we're dealing with. Now, is it all sea level rise? No, there are a lot of other factors. We've had drought, we've had overpumping, we've had the complexity of factors. But we are seeing those changes. We do have some pretty compelling evidence of that. So why is sea level rise rising? Now it's funny that my team of scientists would have me standing up here explaining to you why the seas are rising. I think they decided that if a lawyer could explain it, anybody could probably explain it. So look, I will give this my best shot, and then if you have specific scientific questions, we'll defer. So what's happening? Well, it's getting hotter. I live in Oklahoma right now. When I moved to Oklahoma July 1st, it was 115 degrees. It's not really supposed to be 115 degrees in Oklahoma. Now, whether that's climate change or not is a very political issue that we won't quite take on. But we know, we have the science to know that the Earth is heating up. As the Earth heats up, the water expands. As the water expands, we have more water. Adding to that fact that we have these ice caps that you hear about on the news almost every day that are melting at rates that are more rapid than they were historically. Essentially, there's more water and the water needs a place to go. It needs a home, and that home is our home. So what are the projections for sea level rise? You've probably seen this on the news. This is the graph that was created by the Army Corps of Engineers. And this is the one that all the federal agencies and most of the state agencies are using to consider how to plan for, adapt to, mitigate the effects of sea level rise. Now, you see this big wide swath. This is the uncertainty that you hear people talk about. How much will it rise? When will it rise? We're not going to give you the answer to that today. We are going to show you how the projections work, how much water that would be, where it would be, given a timeline. That is the uncertainty. We do know that the Earth is heating up, that there's more water, that the seas are already rising, that the likelihood is very high that they will rise some more. And so this is what we're looking at. This is the amount of water that we might be looking at on the low end and on the high end in 2060. And Catherine will talk to you in more specific detail about what that means in the basin. So what kind of impacts are we seeing from sea level rise already? We're seeing increased flooding. You're Floridians, you know when it rains, it really rains, and the water needs somewhere to go. Well, this is Palm Coast, and of course Palm Coast has issues of flooding. We're seeing greater coastal erosion. For those of you who love the beach or live on the beach have seen this phenomenon. You know how the beaches change. We're seeing the saltwater intrusion into our aquifers. And we're seeing storm surge come further and further inland. You are well familiar with this picture and the storm surge region in St. Augustine. I was recently informed that there was a nor'easter that caused similar flooding even at a low tide point. So an interesting challenge. We're also seeing the habitat migration and species migration. We talked about the pines and sort of the issues with the pines as the habitats change. This is a very significant impact, and it's very important to the people at the reserve because this is their business. Right? They are in the business of preserving and protecting the native landscape to make sure that there is a home for all of those who live there. You know that small changes can have a big effect based on your community. Fortunately, this isn't you. This is in the South Pacific. But the folks in the South Pacific have been seriously talking about climate change. There are whole island nations that are signing treaties with other nations to find new homes because they know that their time on their islands are limited. So we have a lot of time, right? I just told you that in 50 years we have a graph that sort of does this and there's some variation in it, so you're feeling relieved, right? 50 years is a long time. Let's relax, let's take our time. Well, the challenge is we're already experiencing some effects that we need to plan for. We have challenges with our coastal properties and roads. We have roads that are eroding or being covered with sands. We have stormwater issues. We have water quality issues. We, of course, have emergency preparedness on our minds always. And then there are the natural resources that are changing over time. So while we could wait for 50 years, what we would lose in 50 years' time is so significant that it does require some thought and action right now. What Dr. Frank and I have been talking to our students about is proactive planning. So how do you proactively plan for changes? What kinds of things can we do? We can talk about land preservation. We can talk about infrastructure improvements and where limited municipal funds and state funds are used to do construction. We can move those places that we love. For places special enough, there are pictures of the lighthouse at Cape Hatteras, for example, being moved 3 times because of coastal dynamics. We can encourage development on higher grounds and in the uplands. So One of the presentations that we gave on this topic was particularly troubling to me. We gave a presentation, and I ended the presentation with this gung-ho, we gotta go, we gotta start planning now. And somebody raised their hand and they honestly said, why do I need to care about this? You know, I'm 75 years old, 50 years is a long time, I'm not going to be alive then. And my heart sort of dropped, and so did my jaw. But the reality is, whether we like to say it or not, some of us feel a lot of relief in the fact that this is 50 years off. You know, I think about my age and in 50 years, but then I think about my child, right? And I have a 5-year-old child. In 50 years, my child will get to see this change, will get to live with this change, will get to respond to this change. And so, to me, that is probably the most compelling reason that we need to be having the conversation that we started with you and hopefully continuing on with you.
All right, I'll mix it up a little bit. I'll stand over here. All right, so many of you are probably eager to see what the geographic analyses show for this Matanzas area and in particular St. Augustine. And so I will show you that after just a few slides. All right, so we have a study area, and we're focused, our project is focused on the GTM National Estuary Research Reserve and the watershed that it's in called the Matanzas Basin. But we created a buffer area around our watershed so that we would better understand the context. And so we have included in the buffer area the city of St. Augustine, a large portion of the city of Palm Coast, all the way down to Flagler Beach and the communities in between. So we have results for all this area. Well, we are not the scientists running the models to predict climate change in the future and sea level rise in the future. We recognize that there is a lot of uncertainty in the projections. And so we want to look at a range of futures called scenarios where we look at what's the reasonable low end, the smallest level of sea level rise that we may see, and then the high end. And also the science is always changing, so we can adjust. But we've looked at a wide range of scenarios that we provide data for. And then as the science gets better and as communities make choices about which scenarios they want to plan for, then you have the data available. Now, we can't present all of our results to you, so we're going to focus on one set of results, and that's looking at a 3-foot sea level rise. We found that 3 feet of sea level rise is the point at which the GTM Research Reserve is dramatically affected. Mike talked about loss of the saltwater marshes, and that's one of the dramatic changes that I'll show. Also at 3 feet of sea level rise, we start to see some significant changes in the coastal communities, particularly St. Augustine. And so we'll present that. So we're presenting the 3 feet sea level rise scenario, but then the question becomes, well, when is this going to happen? Is it happening so far off into the future that we don't need to worry about that endpoint? And so that's one scenario. 3 feet sea level rise beyond our planning horizon, and that's on the low end. Now, for I guess the mid-range scenario projection is that this level of sea level rise will occur by the year 2100, so about 85 years into the future. And recognizing that there's all the change that happens in between to get to that point, so it's not that we're just planning for 3 feet, but going up to 3 feet by this time. And then on the high end, we have 3 feet sea level rise by the year 2075. So about 60 years into the future. So what does this look like? Well, to understand our maps, first we have to think about topography, elevation, because a lot of a major factor in the impacts of sea level rise is elevation of the land above sea level, current sea level. And so We found that the topography of this area is like stair steps, where you have a very wide, flat place called a terrace in this illustration. And we have a terrace in the Matanzas estuary where the wetlands are. And then there's a pretty steep step up going to the west, and you reach higher ground pretty quickly and you have the forest. Well, it turns out that if you look at the lowest step being the estuary, the next step up is St. Augustine. And then a higher step would be going to the west. Okay, so that's how you can interpret the maps that I'll show you. So there's another image of steps. Okay, so here is a map showing elevation above current sea level, 3 feet or less. 1.5 feet or less is the red, and then 3 feet or less is the orange. And as we expected, the estuary is largely low-lying and will be dramatically impacted by a 3 feet sea level rise scenario. So this, with that level of rise, inundation would occur on these lands in the red and orange areas. Let's look at an image of a visualization of what it looks like if the Matanzas Basin were inundated with 3 feet of sea level rise. Right, that's Pellicer Creek, which is the border between St. Johns County and Flagler County. So near marine land.
I've always wanted to sit this direction when these videos are
Doesn't Pellicer Creek go up to US 100? So
right, Pellicer Creek is east-west oriented, and it does go up to US 1.
that's all in St. Johns County.
The creek is the border between the county,
Oh.
right, the 2 counties. Okay, and so here's looking at just a different perspective of marine land. So it gives a different impression. Looking at maps is one thing, but looking at it this way makes it real.
Where it was moving.
So marine land is, yeah, I'll point to it. This is the marina, right? The new marina. And then, you see the buildings at the Dolphin Center.
Okay, so all the roads at that time, so almost an island.
Yes. Now, it's a simplified view. It's just looking at elevation. Okay, so here's St. Augustine low-lying places. I said that was coming up. And if you look at a satellite or aerial image of this, you'll see that the low-lying areas are where we have conservation lands to a large extent in the St. Augustine area. And then here's the south of the study area, home coast. So most of the impacts would be in low-lying areas around Beverly Beach, Flagler Beach. Okay, so our ecologically based model is called the Sea Level Affecting Marshes Model, SLAM. And that model looks at a lot of different things, how wetlands can migrate and other movement of sand, and even considers a little bit the amount of saltwater intrusion and how that pushes the groundwater table up. And so that model was run backwards in the Gulf Coast area of Big Bend region where this image is from. And they found that it accurately portrayed the past changes that we've seen. So it's a pretty good model. And so we've applied it to the Matanzas area. First thing you have to do with the model is show the different habitats that are present. And so saltwater marsh is predominant and very important ecologically. Also, tidal flats, we may not think about that as much, but they provide their base of the food chain, and there are quite a few of those in the Matanzas area as well. Okay, so here's what we see for the GTM research reserve when we run the SLAM model, and we see, looking at current on the left, and then with 3 feet of sea level rise, that we have a significant loss of salt marsh, which would be orange, and also the loss of the tidal flats, which is red.
Is that acreage depictive of the loss? So there's 1,700 acres lost?
Right, so that would mean, right, 1,710 acres of salt marsh are lost in the reserve, and 321 acres of tidal flats are lost in the reserve. And remember the stair stepping, that there's no place for them to migrate because the elevation is too high to the west. But we looked at the larger study area, and if there was not development impeding the formation of these habitats in the St. Augustine area, then we would see marshes appearing in this area. And also tidal flats. And so this portrays a more serious look at sea level rise in the St. Augustine area than we look at with elevation alone. Because it's a more complex model, and it looks at tides and groundwater and things like that. Yes?
Have you simulated any storm surges on the throughput rise?
We have simulated storm surges, and what we find is because of the stair stepping, that the sea level rise results in the spread of the storm surge, and about what it is now is just deeper. And across the region, if you look at the developed areas, there's developed land and dry undeveloped land in these areas, then allowing, if the model assumes that these places are allowed to convert to these other habitats, then here's what we see. So in St. Augustine, there's a conversion of developed land to 990 acres of salt marsh, 2 acres of tidal flats, and 2 acres of water. The undeveloped dry land to 504 acres of salt marsh, 1 acre of tidal flats, and 1 acre of open water. And so, again, this is an indication of the degree of wetness that we would see in St. Augustine with the 3 feet sea level rise scenario. And also, if you are concerned about ecological conservation and you wanted to provide a place for wetlands and tidal flats to migrate, then perhaps the undeveloped dry land could be preserved for that purpose. Okay, so we're about solutions, not problems. So let's talk about what solutions may be applied in a little more detail than Dawn gave. She gave some general categories, and I'll give more specific strategies, and this information will help you with your game later. So you can preserve lands in their natural state. You can restore wetlands, we call that a living shoreline. You can even protect uplands for aquifer recharge, so don't develop on them and have all the water run off the surface. You can actually let it go in by keeping land in conservation or forestry. As we're all familiar with, we can make infrastructure investments to fortify our structures, our roads, and raise our buildings. And in terms of moving special places, sometimes our special places are home on the beach, and many of us don't want to move, but if there is a shifting coastline, then legal scholars and government officials are trying to figure out a way to do that through policy, and there's a term called rolling easements that looks at as the water gets higher, the land is more hazardous, and wetlands are migrating, you see under the house in this case, and that the actual definition of what's public land and private land changes, and there may be a point where the owner is willing to sell, and then the government would have that land as conservation. This is just an example. It's not something that we're not advocating any of these strategies. These are just
are looking at in development.
And so, of course, there's planning in general, there's plans, there's a comprehensive plan that can say where a community would like future development to be and how we respond to emergencies and plan for that disaster, how we're going to redevelop, and all these things should be related. If you're looking at where future development should go, it's not just higher ground, it's also where we have compatibility with our natural systems, so we don't want to forget the other principles of good planning in the process. Okay, so thank you very much for your attention.